Today on How It's Made. Police badges. Muffins. Car washes. And pressure gauges. Ever since the days of the American Wild West, badges have been a way to tell the good guys from the bad. Sheriffs don't raise posses to maintain law and order anymore, but a badge continues to be a powerful symbol, and simply flashing one can still stop a suspect cold. The badge comes with the uniform. It identifies the officer's rank and unit, so it's an accessory that makes a statement. Each one is custom made. The client spells out the specifications on an order form, right down to the metal finish and the color of the lettering. This machine delivers a powerful punch to cut sheriff star shapes from a coiled sheet of brass. They place a star shape in the steel mold of a press. It applies about 170,000 pounds per square centimeter to make an impression on the badge. A punch press trims the ragged edges to make it look neater. A mechanical stamper then inscribes the company name on the back of the badge. This computerized engraver then marks the rank and other information on the front. They apply a couple of dabs of silver solder to the back of the badge. It's the substance that will hold the catch and pin joint in place. They blast the back of the badge with a torch, and it reaches a temperature of over 1,400 degrees Fahrenheit. This causes the solder to melt, fusing the parts to the badge. They then position the badge under a hydraulic press. Like a steel fist, it punches the badge to give it the correct curvature. Here, they spray a mix of water and tiny glass beads onto the bag. This is called wet blasting, and it makes the finish cleaner and more textured. A technician now hooks a pin in the joint that was soldered onto the badge. He slides the assembly onto a rivet, automatically served up by this machine. The machine applies pressure to expand the rivet and lock everything in place. The pin now fits in the catch, which will enable the badge to be fastened onto the police officer's uniform. Next, they brush enamel into the engraved lettering. The enamel is a mix of glass and water, which comes from an ancient metalworking technique called cloisonné. They fire the badge in a kiln and the glass enamel melts into the lettering. After it hardens, they grind the enameled sections against a stone to expose the inscriptions. They then polish the badge to a mirror finish. This automated rack immerses the badges in an electroplating solution to give the brass a protective layer of nickel. They plate some badges with 24-karat gold. Now they apply a strong adhesive to the back of a medallion. Then attach it to the center of the badge. The medallion has an official emblem. It's specific to the police force's jurisdiction. They adjust the catch and its hardware to ensure it moves freely and is in good working order. After all, no officer wants to lose his or her badge. They give it a shine and check for surface imperfections. And now it's ready to report for duty. It takes 3 weeks to make one of these police badges, and they should be good for a lifetime of service. The word muffin appeared in Britain around the 11th century. In Victorian times, muffins were bought in the street from the Muffin Man, made famous in the popular children's nursery rhyme. In America, cooks began to experiment with English muffin recipes, and the modern muffin was born. These muffins are a lot like homemade, except to make this many, you need some pretty big equipment and a heap of ingredients. At this commercial bakery, they make them with flour, then add salt, baking powder, and a prepared mixture of dry ingredients. Finally, they add vanilla flavor and start up the barrel mixer. It's a big one, large enough to hold a ton of batter at least. Next, they add oil and water, then vegetable shortening. Now, here come the blueberries. They go into the mix once they're thawed. Berries are delicate, so workers take care to pour them out slowly, weighing each bucket to add just the right amount. Down below, workers pour out close to a ton of batter from the mixer. That's a whole lot of batter. Just one batch makes about 7,000 muffins. They cover the trough to protect the batter until it goes on to fill baking pans like these that can hold 54 muffins, each with its own paper liner. A conveyor advances the pans towards a machine called a batter depositor. Prepared batter pumps in from the trough and into the pans as they pass below it. The depositor fills the pans one row at a time, measuring out the batter by weight. At the next station, blueberries pass through a funnel equipped with a turning gear and drop right onto the muffin tops. A bar placed across the conveyor blows filtered air to remove any stray berries from the pans as they advance to the gas oven. A metal arm pushes them right in to bake for about 30 minutes. The oven, open on both sides, has dampers to keep in the heat. The muffins come out of the oven baked a golden brown. The pans cool for a few minutes and then continue on to a custom-designed machine that's pretty handy. It removes the muffins from the pan and packages them all automatically. Suction cups seize cardboard flats 2 at a time and push them onto a tray former. The forming head pushes down on the pre-glued cardboard and voila! Out comes a perfectly square box that falls right onto the conveyor belt. Pans full of baked muffins follow alongside on another conveyor. At the next stop, suction cups lift the muffins out of their pans. With military precision, they set them down into neat rows in the cardboard boxes that wait on the back conveyor. The conveyor carries the filled boxes to a station where they're covered, top and bottom, with a sheet of clear plastic. Heated blades cut and seal the plastic at both ends. Then the boxes pass through a heat tunnel that shrinks the plastic snugly over the trays. They're now ready for shipping to customers in the food service industry. On another line, pre-printed plastic film wraps the individual muffins as they flow along a conveyor. Rotating brushes keep them moving forward, while blades come down to separate the continuous roll into individually wrapped muffins ready for retail sale. Blueberry, bran, pecan strudel, lemon poppy. With so many flavors to choose from, why not try some of each? The best car washes tackle everything, from road grime and dead bugs to bird droppings that eat away at the paint and metal of your vehicle. Car washes help you preserve your investment and increase its resale value. They save you time and help you feel proud about the vehicle you're driving. A state-of-the-art car wash can be an eye-opening experience. Assorted soaps and waxes clean and pamper every part of the vehicle like never before. This effective yet gentle cleaning power is made possible using the latest car cleaning technology. It starts with welding together the steel frame that travels inside the bay of the car wash. Then adding the steel and fiberglass walls. Using a milling machine, a worker then makes the wheels on which the frame travels. The machine first prepares the center hole where the axle goes, then makes a groove in the wheel so it can ride on a track. Before long, a steel blank becomes a finished drive wheel. He then welds the wheel onto a drive shaft. He places the wheel assembly in the bottom of the steel frame and bolts it in place. He then connects a hydraulic motor to the end of the wheel assembly and makes sure it couples together perfectly. Here, a worker puts together the brush assembly that cleans the sides of the vehicle. The brushes are made of material called Polyflex. It comes cut to various lengths so that it gets into those hard-to-clean places. Polyflex won't trap in dirt particles. It's smooth and very gentle on the vehicle. The finished side brush assembly consists of 7 alternating columns of Polyflex. A worker puts together the pneumatic regulators and gauges that control many aspects of the car wash, including the brush assemblies and the distribution of soaps and waxes. He then bolts the hydraulic pump to the frame. He screws on the system's hydraulic filter, then connects the hydraulic pressure line and makes certain it's secure. The hydraulic power system moves the car wash frame and rotates the brushes, but a computer controls everything. He hooks up the system wires that connect to the computer. The computer makes it possible for the car wash to run without an operator. Workers then install the rack that supports an overhead curtain. A worker attaches a shaft to the rack, then a heavy-duty bearing. When the bearing assembly is in place, he secures the rack to the frame. He tests the rack to make sure its computer-controlled pneumatic cylinders manipulate the overhead curtain correctly. He tests the oscillating high-pressure nozzles. Then he makes sure the wheels move the frame properly. He turns on all the brush assemblies that clean and polish the car and makes sure they spin and oscillate in perfect harmony. The definitive test, of course, is an actual car wash that proves the system works flawlessly and that every part of the vehicle gets the best washing and waxing possible. After a quick drying, this vehicle drives out of the car wash sparkling clean. Life without pressure gauges would be pretty rough. Figuring out everyday things like oil pressure, air pressure, and blood pressure would be almost impossible. Without pressure gauges, we'd even have trouble taking a proper shower because getting the correct water pressure in our homes would be a hit-and-miss affair. For a pressure gauge to be trustworthy, whether it's measuring gases or liquids, it must be exceptionally well made and accurate. To start, a worker loads an aluminum faceplate into a printing press. It applies a colored scale used for measuring pressure in pounds per square inch. The type of scale it prints depends on the measuring unit being used. Then a worker puts a copper tube into a bending machine that bends, cuts, and flattens sections of the tube. The amount of flattening and bending determines the pressure range the gauge can measure. Each piece becomes a pressure-sensing tube known as a Bourdon tube. Then a worker cuts lengths of brass that he machines into connectors. They will link the Bourdon tube to an inlet pipe. He melts zinc solder in the connector's receptacle, and he mounts the Bourdon tube in the correct position. He fills the gap between the connector and the Bourdon tube with solder. Then he flushes the heated piece with water to cool it down, sealing the tube in place. He puts the cooled piece on a mounting fixture and solders the other end of the Bourdon tube to the gauge's internal mechanism. He seals the gap and cools it down. Then he puts the finished pieces, or pressure system assemblies as they are now called, into a cleaning machine. Its hot soapy water washes away any dirt and loose solder particles. The pressure system assemblies then go onto a leak testing machine that pushes air into the tubes. A stable pressure reading indicates there is no leakage. Another worker takes a gear mechanism which controls the mechanical movement inside the gauge and places it on the connector. A machine screws the gear mechanism in place. He then takes the gear's connecting link and rivets it to the pressure system assembly. He fits the pressure system assembly inside a protective stainless steel housing. A machine screws it all together. Next, a worker calibrates the assembly. She loosens up the connecting links slightly to prevent friction, puts on the indicator needle, and runs a test. After a bit more adjusting, she puts the faceplate and the indicator needle back on. She ensures the gauge reads accurately at 3 key positions, and then screws the faceplate onto the gauge. A final test confirms it is calibrated properly. Then she puts a glass cover over the faceplate and adds a steel ring to hold it in place. A crimping machine evenly folds the ring's edge until it makes a perfect seal. Now she fills the gauge with glycerin. Glycerin lubricates the internal mechanical parts and increases the lifetime of the gauge. Glycerin also absorbs vibration well, which helps the indicator needle remain stable during operation. A worker completes the pressure gauge by sealing off the fill hole with a rubber plug. But of course, not all gauges are built the same way. As accurate and dependable as a Swiss watch, a trustworthy pressure gauge also has a pretty face.